All right, well, today we're going to get into adding and subtracting radicals. We're going to do a little exploration here. Um, you should be watching this video when you've completed your math quiz on simplifying radicals. So when you add and subtract radicals, let's just start with when we added 2x plus 3x. When you were taught to add variables, you always were taught to add the numbers that were in front of the variables and keep the coefficients. So you would add 7 plus 2 and keep the x, right? So 2x plus 7x you knew as 9x. And same thing with subtracting. We would subtract the numbers in front of the y's and keep the y. So 15 minus 3 is 12, and we keep the y. Well, the same thing is true when we get into adding and subtracting radicals. All right, if they're both the same radical like you had with like variables, you can add the numbers in front. So think of radical x and radical x as staying the same, they're like terms. You would add the 2 and the 7 in front, giving you 9 radical x. And the same is true with subtracting. Again, you have radical y and radical y, which is like terms. So here you would have 12 radical y. Okay? So radical expressions in which there are like terms can be added or subtracted in the same way monomials are added and subtracted. Okay? So let's try a couple here. Okay? Again, we are going to add the 4 plus 6, and we're going to keep the radical 3. Right? So we would have 10 radical 3 here. And technically, as a number, this is saying 10 times radical 3. Okay? Because that number obviously is going to be greater than 10. All right? When we subtract here, it's like saying 4 minus 6, and we're keeping the radical 3. So 4 minus 6 is negative 2 radical 3. Now if you notice underneath our radicals, we have 3a. That's our constant term. So you're going to have 4 plus 6 minus 5, and we're keeping our radical 3a. So 4 plus 6 is 10, minus 5 is 5, radical 3a. And that's our answer for that one. Now, when we have multiple terms in this one, like we do here, okay? It says, what is different with this example? Well, in this example, if you notice here, you have this term and this term, which is unlike these terms. So that'll be like having an x and a y in the same thing. You can only add the x's together, and you can only add the y's. So in this term, you have two terms are unlike the rest. Okay, meaning the radical 5s are opposite of the radical 15s. Okay, and if they are not like terms, okay, like you see here, the square root of 27 plus the square root of 3 plus the square root of 12. When you have all those that are not like terms, well, what we have to do here, let me move it down here a little bit so we can write on this. It's we have to rewrite the radicals so we can create like terms. This is called simplifying the radical. Which is what we did in the previous section, right? We had experience breaking up the square root of 27 plus the square root of 3 plus the square root of 12. So on the next page, we're gonna show you how to do that. So if I have this, what we want to try to do is I can break down this term and this term. I know I can break those down, but the square root of 3 I can't. So what I want to try to do is think of, well, can the square root of 3 go into 27? Well, it can, because remember, this is 9 times 3. And also the square root of 3 is also in 12 with 4. Well, if you notice, the 9 and the 4 are perfect squares. So when we break these up, this can be 3 and this can be 2. So now when I rewrite the expression, if you look, the square root of 3 plus the 3 radical 3 plus radical 3 plus 2 radical 3, now we have the same numbers. It's like having the same x's. And now what I can do is I can go through and add those, all right? In the first term, I can add the 3. In the second term, there's basically a 1 in front, and there's a 2 in the last term, and we're going to keep the radical 3, which would give us 6 radical 3. So I found basically a common radical between the 3 terms, and we're able to find that. If you look at 58 and 32, well, I know that 1 and 8 doesn't go into 50, but also 2 times 4 doesn't go into 50 evenly, but 2 does. So I know if I break up the first term, I know I got 25 times 2 minus, and then I got 4 times 2 to give me 8 minus, and then I got 16 times 2, because you notice I want to keep all my radical 2's consistent. And the other numbers that I multiply all happen to be perfect squares, square roots, so that the square root of 25 is 5, the square root of 4 is 2, the square root of 16 is 4. So now when I rewrite this, I got 5 square root of 2 minus 2 the square root of 2 minus 4 the square root of 2. And again, now I can take those numbers that are in front, 5 minus 2 minus 4, square root of 2. Well, 5 minus 2 is 3, minus 4 is negative 1. So I'm going to have negative 1 square root of 2, or I can write it as this. Okay. It's kind of like the same thing. We have an x. Instead of writing negative 1x, you just write the minus sign. But this and this are the same thing. All right. In the third example, we have this 2 to the square root of 20 plus 3 to the square root of 45 plus the square root of 180. So what I need to do here, I'm going to kind of cut this off so I know. If I think of the ways that I can get to 20, 1 times 20, 2 times 10, 4 times 5. I'm going to try to find a common root between all these. Same thing with 45. I got 1 and 45. 3 and 15. And 5 and 9. And then 180, I got a few here. I got 1 and 180. I got 2 and 90. I got 3 and 60. 4 times 45. 5 times 16. 6 times 30. 9 times 20. 10 times 18. And 12 times 15. Lots of terms here. But what I'm looking for is a common one between each one, and that would be the radical 5. So this term, and this term would all work. So when I go to simplify this, I'm going to go 2 radical 4 times 5 plus 3 radical 9 times 5 plus, and this is going to be radical 16 times 5. And now my radical 5s are the one that's going to stay, and I'll break up all the perfect square roots, which is 2, 3, and 4. Now when I go ahead and simplify, I need to multiply these two terms because they're outside the radical. So 2 times 2 is 4, so I have 4 radical 5, that simplifies to. In the middle term, I have 9 radical 5, because 3 times 3. And I had a 1 outside, so basically 4 times 1 is just 4. And now they got it broken down, and now I can add. Well, 4 plus 9 plus 4 is 17, and I keep the radical 5. And that is that number simplified. So again, try to think of the radicals as once you get a common one is basically like adding like terms. So it says, what did you notice about these radicals um, after you simplified them? Well, we simplified them to a monomial. Those terms underneath the right, we're talking about one term here, but those terms underneath the radical 5 is 5 that can't be broken up any further. We simplified those radicals all the way down, which is kind of what we learned in the very first section of simplifying radicals. All right. Now, it's not always going to be this way. Okay. Sometimes they're just going to throw you things like this. Well, if I think of what can go into this 18, right? 1 times 18, 2 times 9, 3 times 6. And in 12, I have 1 times 12, 2 times 6, 3 times 4. And in 8, 1 times 8, 2 times 4. Well, if you notice, I got two sets that can kind of work out, right? And this one's kind of on its own, all right? But I want to use this one because it's got a perfect square root. So if I break up each one, okay, and actually I don't want to use 6 times 3. I actually want to use, I'm sorry, I circled the wrong one. 2 times 9, because 9 is the perfect square root. I do not want to use that one. So I got two that are perfect square roots with radical 2's underneath them, and one's going to have a radical 3 with a perfect square root. So watch what happens when I rewrite this. Okay, 9 times 2, that's going to be a square root, plus 4 times 3, plus 4 times 2. Well, when I go ahead and simplify these, all right, I got 3 radical 2 plus 2 radical 3 plus 2 radical 2. So I could only take this term and this term to add the outside numbers together, because this could be like the equivalent of saying 2x, well, I say the 3x plus 2y plus 2x. I could only add these two together because they have like x's. I can't add the y. Well, because of radical 3, I can only add these two together. So I have these two added together at 5 radical 2 plus 2 radical 3. So that would be like having 5x plus 2y. You couldn't combine those any further. And just like here, that would be our answer. We could not combine that any further. All right. So what's different here? They didn't. All the radicals didn't simplify to be like terms. Simplified to the binomial. All right. So we had to simplify. This ends up getting simplified to a binomial instead of up top here, which this is a monomial term. Okay. Well, this is a binomial term because it's two terms, right? So the terms um, all couldn't be simplified the same. Meaning we couldn't get the same number under the radical for all the terms, right? And when that happens, you end up simplifying this. Oops, let's spell that a little bit better. Again, that's why I am a math teacher and not a language arts teacher, but I can spell the word simplified. So this would end up simplifying to a binomial as opposed to the previous example that was actually being able to broke down to a monomial. Okay. So again, this is our little introduction. There is some practice on this. And then actually on Tuesday, we're going to actually um, get into it a little further with multiplying. So hope you found the video helpful, and you can now work on this for practice.